officially the webinar session for today. So good afternoon to everyone. I am very happy to welcome you to this webinar, which is part of a series that is taking place since last year, thanks to the efforts of the AIAC Enzyme Safety Task Force. Many of you are familiar names, so I know that you might be already familiar with the work that the task force is doing. My name is Francesca Angiuli, and I'm responsible for AIZ of coordinating the work of this very efficient task force. And now I will make just a short introduction to explain to you the practicalities for today. So as the first thing, again, I hope that everybody can see the slides and can hear me well. In case you have issues, you can write on the chat. You can write either a private message to me or a message that can be seen to everyone. This chat is also the one that will be used at the end of our presentation today for asking questions, if any, to our presenter. I want just also to remind that this webinar will be recorded. So in case you have issues with that, I have to kindly ask you to leave the room, but I assume it is fine with everyone. So after this short introduction, the only feedback I got from the attendees on the sound was a good one. So I think that Merete, I can leave the floor to you to introduce yourself and start our presentation for today.
Okay, thank you. My name is Merete Simonsen. I am a Senior Science Manager in Toxicology and Product Safety at Novozymes. And I have been given this task of introducing the medical perspectives of working with enzymes this afternoon. So welcome to this webinar. I hope that you will all benefit to some extent from it. This is the outline of the subjects that we would like to address during this webinar. First, there will be a short introduction on the historical background on enzyme allergy. Next, there will be an introduction to the health effect that may arise as a result of airborne exposure to enzymes. Then there will be a section on how to conduct medical surveillance. And this section will be followed by a discussion on the complexity of defining the relationship between the level of enzyme exposure and the sensitization or allergies that may be a result of this exposure. Finally, there will be a summing up on the conclusions, and after that, I'll try and answer those questions that might pop up during my presentation. So let's start with the introduction. First, I'll give some background information to understand what enzymes are and why they are able to cause respiratory allergy. Enzymes are specialized proteins that can be found in all living organisms. Without enzymes, plants, animals, or human beings would not be able to exist. The enzymes are not themselves living organisms, but they are vital for the processes that occur inside an organism. Enzymes act as catalyzers of chemical processes, which means that, for instance, a process that would otherwise require a high temperature or low pH to run will, due to the catalytic action of an enzyme, be able to run at body temperature and neutral pH. Today, enzymes are produced industrially, and they are used as components in, for instance, detergents and as processing aid in the manufacturing of bioethanol, as well as in other industries. Now, what is the history around enzyme allergy? Well, the first enzyme-containing consumer detergent was launched in 1963. The enzyme product, which were added to this and the other very early detergents, were formulated as a powder, so they were very dusty products. In 1969, the first report was published in The Lancet that the enzymes used in the detergents might cause respiratory allergy. This was followed up by the Federal Trade Commission in the US, who questioned that the safety of enzyme products, both in regards to workers and consumer health. The concern was followed up by studies from independent bodies who investigated the extent of the issue, and in 1971 a report concluded that enzymes in detergents do not present a risk to the consumers. Later that year, the US FDA came to the same conclusion, that consumers are safe when using enzyme-containing detergents. However, worker safety was still an issue, and it was clear that improvements had to be made. The situation was improved via a close collaboration between the enzyme suppliers and the detergent manufacturers, which is still running and which this series of webinars is a result of. Improvements were made simultaneously on several fronts. The formulation of enzyme products was changed from the very dusty powder into low dust encapsulated enzymes, which are granulates where the enzyme protein is kept inside. Thereby, the enzyme protein will not be released to the surroundings as long as the encapsulates are intact. Keeping the enzyme encapsulates intact was one of the issues that was addressed when improving the manufacturing sites. Also, industrial hygiene practices and procedures were improved, and medical surveillance and exposure monitoring was implemented during those years. Although a lot of improvement were made and good practices were installed in the early 70s, it is still an issue to be aware of. And without a constant focus on the prevention of enzyme allergies, we may see a situation where the number of enzyme allergies increases due to unawareness by, for instance, new employees or management. Now let's turn to the health effect resulting from airborne exposure to enzymes. Now, what are the health effects that may result from occupational exposure? Well, in the first place, it is fair to emphasize that enzymes generally have a low order of toxicity. That is, there are only two toxicological endpoints that needs to be addressed. These are respiratory allergy, which is an intrinsic hazard for all enzymes, and skin irritation, which is an intrinsic property of enzymes belonging to the class of proteases. I will come back to the skin irritation at a later point in this presentation. It is a fact that due to this rather favorable toxicological profile of enzymes, they are often substituting more harsh chemicals. Having said that, the main safety concern associated to enzymes is a potential to induce respiratory allergy. As mentioned previously, enzymes are proteins, and like many other proteins, they are potential allergens capable of inducing respiratory allergy. This characteristic is also known from common allergens like pollen, house dust mites, and animal dander, and may result in the development of respiratory allergy symptoms like hay fever or asthma. Respiratory allergy, which is also called type 1 allergy, is the only sort of allergy that can be caused by enzymes. Enzymes do not cause allergy via skin contact, and enzymes have not been associated with food allergy. In general, enzymes are neither worse nor better than the common allergens. It is essential to understand that developing a respiratory allergy is a two-step process. It all starts with the individual being exposed to airborne allergens in the form of dust or wet aerosols. If this exposure is sufficiently high and lasting for a sufficiently long period of time, the individual may become sensitized. This is the induction step. A sensitized person does not show any allergy symptoms, but the immune system has been activated and specific IgE antibodies have been generated. The presence of specific IgE antibodies can be detected by a skin test or a serological analysis of the blood. If a sensitized person is repeatedly exposed at sufficiently high level and for sufficiently long time, allergy symptoms may develop, and the person is now allergic. This is the elicitation step. The difference between being sensitized and being allergic is whether or not allergic symptoms have appeared. A sensitized person has no symptoms, and sensitization is not a disease, whereas an allergic person will have allergic symptoms when exposed to the allergen in question. Sensitization is the early warning that an allergy may develop. However, by correct intervention, allergy development may be prevented. Recent literature suggests that for enzymes, the exposure level required for elicitation of an allergy is higher than the exposure level required for inducing a sensitization. If a person develops an enzyme allergy, it will be a workplace-related allergy, and the symptoms may develop during or after working hours. In most cases, the symptoms will disappear when the exposure ceases. The symptoms are identical to those symptoms that are known from allergies towards common allergens, and they are listed in the slide shown on the screen. As you can see, the symptoms shown on the list are shown in order of increasing severity. This is also normally the order of appearance. That is, the first symptoms to appear will normally be the less severe symptoms like watery eyes or sneezing. If the individual is continuously exposed to the allergen for a long period of time, more and more severe symptoms may appear, and in some very few cases, the symptoms may become chronic. For this reason, it is of great importance that intervention take place as soon as possible and preferably before any symptoms appear. Intervention can prevent the development of severe symptoms and that symptoms may become chronic. Now, are there individuals who have an elevated risk of developing an allergy? The answer is yes, but it is rather complex to pinpoint exactly who these individuals are. Some people are defined as atopic, which means that they have allergy towards one or more of the common allergens like pollen. For years it has been discussed whether atopic individuals are at higher risk for developing an enzyme allergy, but until now there is really no clear answer to this. Smoking has been identified as a factor increasing the risk of becoming sensitized and of developing symptoms. In addition to this, it appears that individual susceptibility may vary from time to time. Thus, returning to work after a recent infection seems to increase the risk of becoming sensitized or of developing symptoms. As mentioned previously, some enzymes are able to cause skin irritation. These enzymes all belong to the class of proteases, which is a class of enzymes that can degrade protein. Any other class of enzymes does not possess this characteristic. The irritation will appear as redness of the skin and only after intensive contact. The irritation is local and it will disappear after the skin contact to the protease enzyme has ceased. Skin irritation should not be mistaken for skin allergy, as enzymes do not cause skin allergy. Before going into health surveillance section, it is worth mentioning again that an enzyme allergy is exclusively an occupational health hazard for people working in the enzyme manufacturing industry or for workers handling enzymes as raw materials in, for instance, the detergent manufacturing. Several studies have shown that consumers using the enzyme-containing products on the market today are not at risk. Hence, an enzyme allergy is a result of an occupational exposure, and the cause of it should always be found in the working environment. Okay, now let's talk about health surveillance. Health surveillance is the periodic medical examination of workers who potentially are exposed to enzymes. The objectives of health surveillance related to enzyme exposure are to protect the health of the individual employees by identifying as early as possible any adverse effect which may be caused by the exposure to enzymes. Also, based on a medical assessment, guidance should be given on how to continue working in an environment where enzyme exposure may happen. The results from the health surveillance should be used when evaluating the effect of measures taken to control enzyme exposure. If high numbers of sensitizations are seen in a specific area or department, this is an indication that improvement in control of enzyme exposure are needed there. Further, health surveillance will assist in collecting and maintaining objective data which can detect and evaluate potential hazards to health. Before starting to work in an environment where enzyme exposure cannot be excluded, a pre-employment or pre-placement testing should be conducted. Such pre-employment testing should include a medical history with particular focus on asthma, allergic rhinitis, allergies, chronic lung diseases, or any related diseases, and any medication. Also, a respiratory questionnaire should be completed and an assessment of lung function should be made. A test of the immunological status should be made. This could be a skin test or a serological test. Finally, a physical examination may be carried out. Workers with significant findings such as a history of asthma, allergic rhinitis, or other respiratory diseases or poor lung function should be assessed very carefully. On the basis of history and examination findings, the occupational health professional will make recommendations in accordance with local legislation regarding the employee fitness to work with enzyme products, and of any adjustment or special requirements. During the first 24 months of employment, health surveillance should be conducted every 6 months and thereafter every 12 months as a minimum. The review should include periodic respiratory questionnaire, lung function test, and immunological test. An introduction to these 3 tools will be given later in this presentation. The outcome of health surveillance may be divided into the following options. Those with normal findings may continue to work until the next regular examination. Those who have developed a positive immunological test result to an enzyme but have no other adverse findings may continue to work with enzymes, although increased frequency of surveillance of such workers may be appropriate. Those who has abnormal findings to the respiratory questionnaire, which could be due to enzymes, and those with impaired lung function require immediate further assessment and should be retested within a month or as assessed by the occupational health professionals. Those who show a continuing downward trend in lung function should be assessed as to the need of removal from further work with enzymes. Employees with clinical symptoms of enzyme allergy should be evaluated by the occupational health professional regarding their fitness to continue their work. It is important that employees are trained to recognize symptoms that may be related to enzyme exposure, and that they are encouraged to report such symptoms to the occupational health center. The results of workers' immunological tests should be given directly to each employee. This result is important for the individual employee since it may help to identify and correct any individual contributory or causative factors, such as failure to follow job safe practices. Each case of sensitization should be evaluated by a workplace investigation conducted by an occupational health specialist. Group results of immunological tests also contribute to the evaluation of workplace control measures. Such group data can be used to monitor the effectiveness of hygiene and engineering programs that are installed in factories or within individual departments. Group data will help to prioritize areas for improvement. As previously mentioned, these are the three basic tools in medical monitoring, and we will now go through them one by one. It is not possible in this presentation to go into every detail regarding these basic tools. Instead, I will refer to the AISE guideline on safe handling of enzymes, in which you will find a comprehensive description of the tools. The guideline can be found on the AISE webpage, and you can use the link inserted in the slide to download it. Applicants for a job should complete a general health questionnaire at pre-placement, and this questionnaire should include questions relating to previous employment and any exposures to chemicals, fumes, or dust. The intent of the pre-placement respiratory questionnaire is solely to detect existing respiratory symptoms and to give a good description of such symptoms. Also, at the regular or periodical testing, a questionnaire should be completed to follow up on any changes since the last testing. In the AISE guideline for safe handling of enzymes, examples of such pre-employment and periodical questionnaires are given. A link to this guideline is given on the slide. The questionnaires are based on the questionnaire published by the International Union Against Tuberculosis and Lung Disease. The occupational health specialist should assess the significance of any reported symptoms and should identify any smokers, as smokers may have an elevated risk for sensitization. When performing a lung function test using spirometry, it is important that an accepted standardized procedure and protocol is followed to reduce measurement errors. A detailed description of such procedure can be found in the AISE guideline on safe handling of enzymes. Spirometry should be conducted by trained and competent staff, since testing and interpretation require both skills and training. The parameters to be measured are forced expiratory volume in 1 second, FEV1, forced vital capacity, FVC, and the ratio between these two parameters. The forced expiratory volume in 1 second is the volume of air that can be forcibly blown out in 1 second after full inspiration. The average value of this parameter will in healthy people depend mainly on sex and age, as well as on height and mass. Values between 80% and 120% of the average value are considered normal. Forced vital capacity is the volume of air that can be forcibly blown out after full inspiration. The ratio between FEV1 and FVC should in healthy adults be approximately 70 to 85%, declining with age. In obstructive diseases like asthma, this ratio is reduced, often down to 45%. Peak expiratory flow rate, PEFR, is the maximal flow or speed achieved during the maximally forced expiration. This is measured in liters per minute or in liters per second. A minimum of 3 trials for lung function tests should be completed to check for reproducibility. Once acceptable and reproducible spirometry results have been obtained, the results should be interpreted by a trained and competent person. The purpose of immunological monitoring is to monitor the appearance of sensitization among the workforce. That is, to monitor the development of specific IgE antibodies. It is important to remember that sensitization is not a disease. It is an indication that a person has been exposed and may be on its way to develop an allergy. By monitoring the immunological status of the employee, it is possible by intervention to prevent the development of an enzyme allergy. Two methodologies are generally used for monitoring the immunological status among employees, and these are skin prick test or serological test, which is an analysis of a blood sample. A detailed description of both methods can be found in the AISE guideline on safe handling of enzymes. Sorry. Both methods for monitoring the immunological status among employees are robust methods. However, both methods also have advantages and disadvantages, of which the most important are listed in this table. For skin prick testing, it is a big advantage that the result is obtained almost immediately, and that the method is relatively inexpensive. The disadvantages of the method are that it requires a high level of training and skills of the staff that conducts the tests, and another disadvantage is that the method does not produce a quantitative result. The response obtained will be a yes or no response in regards to sensitization towards the allergen in question. For serological testing, the major advantages are that the results obtained is quantitative, that the analysis for more allergen can be conducted on the same blood or serum sample, and that serum samples can be stored for analysis at a later point in time. The latter could be relevant if at some point it becomes necessary to investigate for sensitization towards another allergen than previously investigated for. The serological testing does not require specially trained nurses or staff on site, but it will require the serum samples to be transported to an accredited or certified laboratory. Using an accredited or certified laboratory is important, as otherwise false positive or false negative responses may be obtained. It is a disadvantage of the serological testing that the results of the testing is not obtained immediately. Also, the fact that the serological testing is relatively expensive can be considered a disadvantage. The relationship between occupational exposure and the development of sensitization or allergy is very complex. So let's have a quick look on what we know and what we don't know. The relationship between airborne exposure to enzymes and the development of sensitization or allergy is today only poorly understood. The reasons for this lack of knowledge are many, but among the most important are the facts that we do not have any animal models which could be used to provide information on this relationship or to provide information on no effect levels. Most data on human exposure to enzymes are based on exposure monitoring for 4 to 8 hours in a specific area. This type of data do not allow for peak exposures to be identified, and hence the contribution of such peak exposures is not really accounted for, although it is generally recognized that peak exposures play a vital role for both sensitization and allergy development. However, we do have some knowledge on the relation between airborne exposure to enzymes, and the development of sensitization or allergy. We know for sure that when the exposure is in control, this will lead to a reduced number of sensitizations and resulting in only low risk of symptoms. It has been shown that among the exposed workers, some may become sensitized, but only a limited number of these sensitized persons will develop an allergy. In addition, it appears that the development of allergy occurs at a higher exposure level than the exposure level required for developing sensitization. We also know that a no effect level do exist, but our present techniques do not allow us to quantify this low no effect level. Instead, starting point for a derived minimum effect level, a DMEL, has been established both for occupational exposure as well as for consumer exposure. The DMEL starting point for occupational exposure is 60 nanograms per meter cube, and for consumer exposure it is 15 nanograms per meter cube. In 2015, a study conducted by AISE and the American sister organization ACI was published showing exposure data and health surveillance data from more than 100 detergent-producing factories for a period of 5 years. More than 20,000 workers participated in this study. From this very comprehensive study, it can be seen that when exposure is in control, the incidence rate of new sensitizations, that is, the percentage of new sensitization per calendar year, will be down to approximately 1%. Among that 1% of newly sensitized individuals, only 10% will develop an allergy to enzymes, or to put it in another way, only approximately 0.1% of the workforce will risk developing an enzyme allergy. These data are very reassuring and show that it is possible to keep the incidence of enzyme allergy down to an acceptable number if the exposure is in control. Having been through this presentation, what are the main conclusions to be drawn? The main conclusions to be drawn from this presentation are that a health surveillance program should be established when occupational exposure to enzymes may occur. Such a health surveillance program can identify workers that have become sensitized, and intervention and close follow-up on sensitized workers may prevent them from developing an allergy. In case that allergy symptoms are already present, the intervention may prevent that these symptoms become more severe or even chronic. A health surveillance program with high participation rate may provide group results that can help documenting a healthy workplace, or to identify area-specific issues related to, for instance, equipment, processes, ventilation, behavior, etc. Finally, experience shows that good communication with employees is absolutely necessary to harvest all the benefits from a health surveillance program. Without a good and positive contact with the employees, they may not want to participate in a health surveillance program or to come forward if they should experience any allergy symptoms. This concludes the presentation, and it is now time for any questions that might have popped up during my speak.
Thank you very much, Merete. It was a very, very clear presentation, and I have to say that also my understanding improved quite a lot about the topic thanks to the information that you gave today to the group. So I have not received any questions for the time being. Now, what I would like to say to the attendees is that if there are any questions, they can write to us by using the chat that is on the right side of our panel. I will now leave you a bit of time in case you intend to ask some questions on the content of this presentation to our presenter today. I also would like to inform you that in case some questions might come up later on in the coming days or in the coming weeks, you're always welcome to contact us with your questions. We will show you later on our address, but it is webinar at aiac.eu. And this address can be used to contact us in case of questions. And again, also the recordings from today's presentation together with the slides that Merete showed to us will be also published online in the coming weeks. And I will send an email to you once that is done. So Merete, I have received a question from the audience. So if a person can develop allergic symptoms from one peak exposure, or it is only by repeated exposure?
Well, it's a very, very good question, and there is, in fact, no clear answer to that. This is a question that has been discussed for many, many years, I would say. I think that there is kind of consensus that actually both issues are of importance in developing an enzyme allergy. I would say that if you have a very long exposure, long duration, and of a certain level, then of course that will be of importance of developing an enzyme allergy. On the other hand, we also know that the peak exposures may be those exposures that could actually lift you from over the induction step or the elicitation step.
Okay, so let's see if this answer the question or some other clarifications are needed. I see that someone is typing, so okay, so your answer was clear and complete.
Thank you.
So it seems that there are no other questions for the time being raised on the topic of the presentation. So what I would like again to remind is that the address that you see on the screen can be used to forward question in case you have any after the presentation today. I also would like to let you know that in the coming weeks we will post on our webpage some slides related to the enzymes management in safety, and these slides will not be presented in a live session, but you will be informed once they are available online. And there is still another live date for our webinars that will take place in May, and updates on that will also be posted on our webpage. So it seems that indeed your presentation was probably too complete, Merete, so this is why we don't have questions popping up at the moment.
No, that's fine.
I would like to take the chance to thank you again, Merete, for the work you've done to prepare the presentation, and to thank everyone who attended the webinar today for joining us. And from my side, this would be everything. So I will now close the meeting, and again, we will be in touch after this webinar again, and probably see you in our next recording. Thank you very much, everyone. Have a nice afternoon.
Thank you.
Thank you. Bye-bye.